Welcome to this Superspace short, and I want to talk about how when we are looking at gravity and the curvature of gravity going inward, we are actually looking at the curvature into the fourth dimension. And when we try to understand gravity curving into infinity, how that shows that the curvature at some point moves in a direction rather than continuing to curve, just as when we talk about small, at some point things are not getting smaller, but are moving in that fundamentally fourth direction of the fourth dimension that we think of as the very small. So when in my usual 2D analogy, we think of space as a flat 2D plane, then the curvature of gravity, it's a curvature, so it's curving space, but then at some point that curvature is no longer curving, it's moving in this fundamentally different spatial direction of the fourth dimension, which is in the direction that we think of as the very small. Now, although this realization is not, physics does not currently realize this or recognize this, you can find it in the math and in the concepts and in the discussions of gravity, of infinities in the math, of objects such as black holes and so on. So I was looking at this discussion of gravity here, where an individual is showing up here, if you can see me making a little circle with my mouse, this is the classic picture that shows gravity as the curvature of space. So it would be like a bowling ball on a flat sheet, bending that. And the individual wisely is showing how it's a little more complex, that if you actually try to look at it in 3D space, it is clearly a more complex picture. And what I wanted to show is that if you look at these lines actually can only be curving inward. There isn't another spatial direction to go in, even if we talk like there is, and say it's somehow to right angles of everything we know, etc. These lines are actually curving inward to the point where they are no longer curving into what is smaller, but curving inward into that fundamentally different fourth spatial dimension, that is the realm of the very small. And before I look at the idea of wormholes, let me just really quick pull up this video, which is the same as this this picture. And so if we look at this, you'll see how the lines in here, yeah, let's just play that a little bit. You'll see how the lines are going in, and that is actually the experience of gravity. Now, I'm not going into this person's explanation, and again, I'm using this under fair use just as a brief clip of the graphic here, but I believe it is intuitively right in the sense that gravity is not just curvature, but there is a movement there, which I show is the movement of time through the fourth dimension. But if you just look at the image, you see the curvature.
Earth, because it is very massive, deformed space-time, giving it a curvature.
So, a massive object deforming space-time to give it a curvature, but those curving lines do go inward.
For us, the curvature of space-time appears as an endless contraction of the...
And again, I won't go into this particular individual's explanation of what he's saying, but the graphic is actually quite wonderful in the sense that it shows the experience we have of gravity, which is this motion in a fourth spatial direction, but that motion is an inward one. Inward is that one direction that can actually explain what we are observing and what we're seeing in the math. And as a final point, I want to look at this article that talks about wormholes, because again, when we're examining the math, we're seeing all of these solutions to what looks like directions leading outside of our universe, but we're just not recognizing them as the direction of small. And so here it says, the researcher then considered what would happen if the black hole emerged in a distant realm. For instance, it might come out in another universe. In that case, etc., right? It might come out in another universe. But we have to understand that these spatial dimensions that could lie alongside our own 3D space are in what we think of as the realm of the very small. And so if we just look at this graphic right here, according to superspace theory and what is actually the case, and I will have to actually make this a little smaller just because the graphic has a lower resolution. But what we know from superspace theory, and what we will recognize in physics at some point, is that if we saw this as the sheet of our universe, this direction, this curvature, is not going to some other strange dimension that cannot be comprehended. It is moving into the realm of the very small, and there are fields, spatial fields, as we move in the direction of what we think of as the very small. And that is exactly what a wormhole would be. It would be moving in the direction of small. And bodies and particles are holes that open into this fourth spatial direction of the fourth dimension, which is what we think of as the realm of the very small. And that is what is in the mathematics that make us think there's a singularity, an infinity point, an infinite point, but actually isn't talking about a point, it's talking about a direction. When we think about wormholes, etc., we need to recognize that our field of space does lie alongside deeper fields of space, dimensional fields that are, well, conceivably three-dimensional like our own, but that this direction is what we think of as the very small, or the inward direction. And that's the only thing we have to recognize to come to a new understanding of what our math is saying and what these concepts actually mean. Thank you for watching.